In the last video, we have found that the particular values are zeros of the given polynomial. By substituting that value, we found that the value of the polynomial becomes 0 and declared that values are zeros of the polynomial. How we have found it, we have not discussed about the way in which we are finding the zeros. In this video, we are going to consider the method of finding zeros of the polynomial here. And finding the zeros of the polynomials by method of factorization, factoring the polynomial into linear polynomial. And fundamental here, I would like to mention the fundamental theorem of algebra. Every polynomial of degree n has n zeros. And factorization, we mean if alpha 1, alpha 2, alpha n are the zeros of the polynomial, px is equal to an x raised to n plus an minus 1 x raised to n minus 1, etc. plus a naught. Then px can be written as an into x minus alpha 1 into x minus alpha 2, etc., etc., x minus alpha n as a factor, linear factors, product of linear factors, which you can write down by the help of the given zeros. Now, zeros of a constant polynomial and a linear polynomial. Now we can see constant polynomial where we can see the px, the value of px, whatever may be x, px, it remains constant. And never become zero. It becomes zero when it is going to be zero. That is also one of the constant polynomial. In that case, zeros of the polynomials are all real numbers. And therefore, we can see here the constant polynomial has no zeros. Now, the linear polynomial, we can see here linear polynomial equating what you can say equating ax plus b equal to 0 implies x is equal to minus b by a becomes 0. And hence this is the linear polynomial, which you can find out very easily about the zeros of the linear polynomial. Now we can consider zeros of the quadratic polynomial. Now here an algorithm to factor px into two linear factors. Given the quadratic polynomial, we have to write this polynomial into a product of two linear polynomial, and this I would like to put it in the form of algorithm. Multiply a and b and A and B, the product of A and B, let it be C dash. And 2, choose two numbers alpha and beta such that alpha plus beta is equal to B and alpha into beta is equal to C dash. Factorize Bx by adjusting the term, middle term Bx suitably by using alpha and beta from the step 2. Equate each of the factor to 0 and then get the two zeros of the polynomial. Now observe, I would like to take one example here. Find the zeros of the Px equal to 2x square minus 5x and minus 3. Here 2 into 3 is equal to 6. And partition minus 5, partition minus 5 into two numbers. Now look at the factors of 6. So can write down this as 2x square minus 2x minus 3x minus 3. You can write down this one. And now this can be written as 2x, you can take out common factor, x minus 1 minus 3, that is minus 3 into x plus 1. I'm sorry, here plus 3. Plus 3 minus 3 you can take out from this. This is going to be what is that? X minus 1 into 2x minus 3, and this is going to be what is that? X, equating these two to 0, and therefore x minus 1 equal to 0 and 2x minus 3 equal to 0, and therefore x is equal to 1 and x is equal to 3 by 2 are zeros. Of Px. In this way we can factorize the given quadratic polynomial into two linear polynomial, and thereby we can get the what is that zeros of the quadratic polynomial. If you just change in the constant term, change minus plus 3 by minus 3 in the above example, in the above polynomial, we get qx. I can write down this is equal to 2x square minus 5x minus 3. Then here 2 into minus 3 is equal to minus 6. So we can change the middle term as 2x square minus 6x plus x minus 3 is equal to 2x. You can take out from this one, x minus 3 plus 1 into x minus 3, which can be written as x minus 3 into 2x plus 1, equating to 0. We get x equal to 3 and minus 1 by 2 as zeros.